Now let's start talking about derivatives of transcendental functions in the chain rule. So for this here, we want to focus on the 6 trigonometric functions: sine, tangent, secant, cosine, cotangent, and cosecant. And so you can see here, all right, I'll just start with this one. So sine of u. So u, this u inside here, u is a differentiable function of x. Differentiable function of x. So when you go to apply the chain rule, okay, this, what's inside the trig function, so the u is the inside and the trig function is the outside, right? So you take the derivative of the outside, so the derivative of sine we know is cosine, evaluated at u, and then you multiply that by the derivative of the inside, or u prime. So it'd be the same thing for tangent. Tangent of u, derivative of the outside here is secant squared of u times the derivative of u, which is u prime. Derivative of secant u, derivative of secant u is secant u tangent u times u prime. Derivative of cosine of u, so derivative of cosine is minus sine, so this is minus sine of u times the derivative of u prime. Cotangent, so the derivative of cotangent of u is minus cosecant squared of u times u prime. Derivative of cosecant of u is minus cosecant of u cotangent of u times u prime. Okay, the last one here, if you have the derivative with respect to x of e to the u. So the e here is the outside, and the u is the inside. So the derivative of the outside, derivative of e to the u, just start with e to the u, and then you're going to multiply it by u prime. Okay, so the derivative of the inside. All right, let's do a number of examples here, just so you can see just specifically these derivatives here. All right, so we'll do a bunch here. So let's find the derivative of the following. So the derivatives of the following. So let's start with this one here, right? Let's just even do just a very simple recap. Okay, if I say y is equal to sine of x, just sine of x, we know then that dy dx here, we just even know that derivative of sine is just cosine. So this is just cosine of x. But look here, what if I have this? Y is equal to sine of 3x. No, it's no longer x here. All right, it's 3x. So my sine here is my outside, and my 3x is my inside. So if it helps to see this, let's let u be the inside, 3x. So then y is equal to sine of u. So that means this y prime, the derivative here, y prime, is equal to, look, sine of u. It's cosine of u times u prime. So it's cosine of u times u prime. So y prime then here. Well, cosine of u, I said u was 3x. So this is cosine of 3x times, and then the derivative of u prime here, derivative of u prime is just 3. So this here is equal to 3 times cosine of 3x. Let's try this one. And I'm going to do it without the u stuff, the u substitution. I'm going to just say derivative of the outside times derivative of the inside here. Let's look at the derivative for f of x is equal to secant of x squared. All right, so notice here, okay, derivative of secant of u. So what is my u here? This is just if it helps to see it, this is secant of x squared. Okay, very, very important. I'll do a trigonometric function squared in a second, but my inside here is just x squared. Okay, so that's my u, and secant is my outside. So f prime of x, the derivative here. Derivative of secant is secant u tangent u. So this is secant of x squared times tangent of x squared. And then the derivative of the inside, derivative of u prime, well, the derivative of x squared is just 2x. So I'm going to write this as 2x times secant of x squared tangent of x squared, just like that. All right, let's try this one here. This one's actually going to be pretty tricky. I'm going to have f of x is equal to, let's look at cosine squared of x. And then I'm going to do another one. I'm going to mix it up even more. All right. So this right here, f of x is equal to, right? When you have this cosine squared, this is cosine of x squared. So now watch when I apply the chain rule here. Okay, my inside is cosine, and my outside is the squared. So f prime of x here is equal to, take the derivative of the outside, so bring the 2 down, cosine of x. 2 minus 1 is 1, and then the derivative of cosine, you can even cheat here, it's minus sine. So minus sine of x. So f prime of x is equal to minus 2 times cosine of x times sine of x. All right. Let's take this same problem here, okay? This same problem, and let's make it even a little bit harder, okay? So you can see the subtle difference here, all right? So let's find the derivatives again of the following. So I previously had cosine squared of x. So let's look at this. Let's look at f of x is equal to cosine squared of 4x. Okay. So look, this is equal to cosine of 4x squared. All right, so when I take the derivative here, okay, you're going to notice that this is going to be a chain rule problem. You're going to have to apply the chain rule twice. All right, so this cosine of 4x is my inside, the squared is my outside. So f prime of x is equal to, I'm going to bring the 2 down, times cosine of 4x. 2 minus 1 is 1, so that's good. And now I need to multiply by the derivative with respect to x of the inside, which is cosine of 4x. The reason I put it, that I still have to take the derivative of the inside is because, look, if we're going to take the derivative of this, I have to apply the chain rule here. Inside, outside. So this is 2 cosine of 4x. Derivative of the outside, so look, derivative of cosine minus sine. So this is minus sine of 4x. And then the derivative of the inside, derivative of 4x, is another 4. So 2 times 4 here, and the minus, so this gets me minus 8 cosine of 4x times sine of 4x. So it's a chain rule twice problem here. Let's do another one of these chain rule twice problems so you can see what's going on here. Let's look at, let's try this one. Let's try y is equal to the square root of cosine of 2x. So this is y is equal to, in parentheses, cosine of 2x to the 1/2 power. Okay. So you're going to need to apply the chain rule here. So dy dx here. Bring the 1/2 down. Leave the inside alone. So cosine of 2x. And then this becomes 1/2 minus 1 gets me minus 1/2. Now the derivative of the inside. Derivative of cosine here is minus sine of 2x, but then I also have to take the derivative of the inside. All right, so the derivative of 2x is just 2. So then look what happens here. The 1/2 and 2 cancel. So you're just left with cosine of 2x to the minus 1/2 power times don't forget the negative, minus sine of 2x. So this is equal to, just bring this down, minus sine of 2x divided by, and then the negative 1/2 comes down as the square root of cosine of 2x. All right, let's try this one. I'm going to do two that involve e now. So going back, all right, we see that the derivative with respect to x of e to the u is e to the u times u prime. So if y is equal to e to the 4x cubed, okay, dy dx, leave this alone. So the first you get is e to the u. So this is my outside, and this is my inside. So you get e to the 4x cubed times, and then you take the derivative of the inside. So this 3 comes down, you get 12x squared. So I like to put the 12x squared in front. So I would write this as 12x squared e to the 4x cubed. All right, let's end on this one here, okay? Let's look at y is equal to e to the 3x times tangent of 5x. So if you look here, what you're going to need to apply is you're going to need to apply the product rule, right? So when you apply the product rule, though, you're going to have to take the chain rule of each of these. So dy dx is equal to, what is the derivative of e to the 3x? It's e to the 3x times 3. So that's 3 e to the 3x times tangent of 5x plus, and now look, what's the derivative of tangent of u? So tangent to the 5x. It's secant squared of u times u prime, right? So leave the e to the 3x, that stays. Derivative of tangent we know is secant squared of 5x. And then you would take the derivative of 5x. Well, the derivative of 5x is just 5. So I'm going to just leave it like this. I mean, you could factor out the e to the 3x. And you're left with 3 tangent of 5x plus secant squared of 5x. Like that. So again, just follow the formulas, right? That's really what's going on here. And don't forget, when you take the derivative of the outside function, don't forget to take the derivative of the inside function. So again, just follow all these formulas, be meticulous, take your time.